some stuff with this function e, and really functions with e, and we're going to really look at functions with e to the x. And I need to review a couple things with you. First of all, the product rule. The product rule for differentiation. If you differentiate the product of two functions, f times g, when you differentiate those, you get f prime times g plus f times g prime. And you know you're going to use the product rule when you say the word times when you read it out loud. So just remember that. Remember, just for sake of remembering it, the quotient rule. That's a little easier to see when you would use it, but that's when you have a function f divided by a function g. And you do the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, so that's the product rule and the quotient rule. Remember that when you differentiate e to the x, you simply get e to the x. Now, you are going to have to know that if you differentiate something that is other than just x, you will have to use the chain rule. So you will have to use the chain rule. So this is a chain rule thing. Okay, so just know that. So now, sorry, that was my wife calling, but I'll talk to her later. So now, the other thing that you got to remember is that if you graph a function e to the x, one thing that you need to know is it's always positive. Okay, so the range is always positive. And I guess that's the biggest thing, is that that's always positive. So when you factor it out, you know that that e to the x is always positive. This is what the graph looks like. So it's really important that you know that. I guess the other things you need to know is e to the 0 is equal to 1. And so that's another thing you just need to remember. Okay, so let me show you one example, and then if I need to do more examples, I'll maybe do more examples, but I don't want this video to get too long. So let me show you one example, the kind of problem that you're going to have to do for this. So let me rearrange a couple things here. It'll be a problem like this. And it uses the chart, right? So it's going to use the chart again. So if we look at this, it says, find all the values f of x equaling negative x times e to the negative 2x, where we have a relative maximum. So we need a relative maximum for f, which would mean that f prime is going to go from positive values to negative values, according to the chart. So what we're going to need to do is we need to take a derivative. We need to figure out what f prime of x equals. F prime of x is negative 1 times e to the negative 2x plus negative x times e to the negative 2x times negative 2 because of the chain rule. So go back and review your work on chain rule stuff, but that and product rule. But that's a product rule, chain rule kind of thing. So let me just rewrite it real quick here. So I got f prime of x is equal to negative e to the negative 2x plus 2x e to the negative 2x. And notice that I can factor out an e to the negative 2x. So if I factor that out, I'd have negative 1 plus 2x right there, right? So remember, we just talked about this is always positive. Okay, so that's not going to change anything. So that part is always positive. You know, if you graph that, that graph is an exponential decay function that kind of looks like this, something like that. So what you need to figure out is when -1 plus 2x equals 0, because that's going to be our when we're trying to find when the first derivative changes signs, that's what we need to figure out. So that's when 2x is equal to 1, so that's when x is equal to 1/2. Now, when we kind of look at this and we kind of say, okay, we got x equals 1/2 here. If we test, we kind of look at testing some values. If we test x equals 0 over here and x equals 1 here, and we kind of figure out what is f prime doing. Now, here is f prime. Let me highlight it in green. This is f prime right here. Notice that when we put in 0, we get 1 times a negative. So we get a negative value here. Okay, because if you put in 0 into here, you get 1, you get a negative here. If you put in 1 into here, notice we have a negative, we have a positive value, because that's always positive, times another positive, so this is positive. So when we look at this, we go, okay, wait a minute. We went back up here. We needed f prime to go from negative to positive. At 1/2, f prime goes from negative, or sorry, we needed it to go from positive to negative up here. Remember, way up here? In order for us to have a relative maximum, f prime needed to go from positive to negative. We only found where f prime goes from negative to positive. So this value right here is the empty set. So if I put the empty set in there, submit the answer, that's going to be my thing. We don't ever have a place where that works. So that's the kind of thing that you're going to have to do on these problems. If you need help, let me know. Again, it just works with the chart.